I will be working the problems from 2.3. I will start with number 1. We have f of x equals 2 to the 40th power, and we're asked to differentiate the function. No work to be done here. 2 to the 40th power is a constant, and we know that the derivative of a constant is always going to be 0. So remember that if c is, we have a constant c, the derivative of it is always 0. This is a constant, so f prime of x will be 0. Number 2, exactly the same, pi squared, that's a constant, so derivative is 0. So let's move on to number 3, a little more interesting. We have f of t is 2 minus 2/3 t. f of t, 2 minus 2/3 t. All right, now we get to start using some of the rules here. So we have a function that is the difference of two functions. You can look at that as its own function. This is its own function. And so the rules of differentiation allow us to take the derivative of each one. So this derivative will be equal to the derivative of 2, whatever that is, minus the derivative of 2/3 t. Now the derivative of 2, because 2 is a constant, is 0. And then minus, now over here, I have a constant times the function, right? A constant times a function. Whenever we have that, that constant will just come along for the ride, and then all we have to do is take the derivative of what the function is, in this case, the derivative of t. And the derivative of t is 1. That's just something we should know. Derivative of x is 1. But the reason why is because we start with t to the first power. That's t. When we take the derivative of it, we move the power out, 1. Then we have t, and then we subtract 1 from the power, 1 minus 1. This gives us 1 times t to the 0, and t to the 0 is 1. So we get 1 times 1, that's 1. So we should get 0 minus 2/3 times 1, which should just be negative 2/3. And if you think about this a little bit, the derivative, remember, was the slope of the tangent line, and this function is a linear function. This looks like y equals mx plus b. So the slope of this line is this, negative 2/3, and so if you're on that line, the slope is negative 2/3, go to any point, the tangent line will also be negative 2/3. We'll have a slope of negative 2/3, which is what we're saying here. So it matches up with what we would think would happen. All right. Number 4, f of x equals 3/4 times x to the 8th. Capital F of x equals 3/4 times x to the 8th. So the derivative of capital F, well, we have a constant again times a function, so that's just going to come along for the ride, times the derivative of x to the 8th. And now I'm going to use that rule again, that if I'm trying to take the derivative of x to the 8th, the 8's going to come down in front. I'll have x to the 8, take away 1, that's 8x to the 7th. So this will become 3/4 times 8x to the 7th, and then of course 4 goes into 8 twice, so we'll just have 6x to the 7th. There we go. Number 7. Wait a minute, hold on. Yeah, number 7. Number 7 is f of x is 3x squared minus 2 cosine x. Wait a minute, am I doing the right one? Oops, sorry, I knew I was missing something. What about 6? Okay, f of t equals 1.4 t to the fifth minus 2.5 t to the second plus 6.7. We're asked to differentiate the function. So we're going to try to find the derivative using the shortcuts. All right, so I have 1, 2, 3 terms. I can differentiate each one separately. The 1.4 comes along for the ride because it is a constant attached to a function through multiplication. I will need to take the derivative of t to the fifth. Minus 2.5 times t squared, so the minus 2.5 comes along for the ride. I'll need to take the derivative of t squared, and then plus the derivative of a constant, which I know is going to be 0. I forgot my prime. All right, so the derivative of this, okay, I'm going to have 1.4 here. The derivative of this, the 5 comes down in front, and then we subtract 1 from 5 and get 4. Then we have minus 2.5, and then same thing here. 2 comes down in front times 2. T to the, subtract 1 from that power, we get 1, so just t. And then derivative of this constant is 0. We don't need to write it, I'm just putting it there. So now we need to multiply, clean this up a little bit. 1.4 times 5, that's 5.4, I believe that's 7. 7t to the fourth. And then 2 times 2.5, that's going to be minus 5t, and then plus 0, so that's it right there. Okay, moving along to number 7. F of x equals, what was it, 2x? 3x squared minus 2 cosine x. All right, 2 terms. So I can do the derivative by just doing the derivative of each one. I have a product right here, constant times the function, so the constant comes along. I'm going to take the derivative of x squared. And then I have another constant times a function, so minus 2 comes along, and I need to take derivative of cosine x. So this just becomes 3, and then derivative of that is 2x, and then minus 2, and then the derivative of cosine of x, which we talk about in class, is negative sine x. And now we can clean up a little bit. We have 3 times 2 is 6, so 6x. And then we have a negative 2 times a negative sine x. Negative times negative is positive, so I'll put plus 2 sine x. That's it. Number 8. Y equals sine t plus pi cosine t. All right, so I want the derivative, so my notation's a little different here. Derivative of this, I write y prime equals, now I have 2 terms, I can do them separately. The derivative of sine of t, whatever that is, plus pi times a function of t, so pi comes along, and then I need to take derivative of cosine t. Derivative of sine of t is cosine t plus pi, and then derivative of cosine t is negative sine t, and that means cosine t, and then we're adding, but this is going to multiply to be a negative, so it's going to turn to subtraction, minus pi sine t. Done. All right, pretty straightforward so far. Okay, number 9, x squared times 1 minus 2x. F, what is it? G of t. G of x. X squared. My brain is not turned on yet. It's Friday morning. It's like 8 o'clock in the morning. So I apologize ahead of time. All right, we want to find the derivative. So we want to know g prime of x. Now, This problem is different than anything we've seen so far because I have a product, right, of a function of x times another function of x. And the big mistake that people make is they just say, okay, I'll just take the derivative of this and then take derivative of this and just put the answers and multiply them. That is not correct. We actually will tackle that in the next section. How do you deal with products? But because this is a pretty easy multiplication to do, we'll just distribute through first. This will give us x squared and then minus 2x cubed. Now we don't have the product anymore. We have two terms and we can just take the derivative of each one. So I'm going to start moving a little faster, okay, because you've probably, hopefully, picked up on this. The derivative of this one, the 2 comes out, we just get 2x. And then the minus 2 comes for the ride. And the derivative of x cubed is 3x squared. So just clean it up. 2x minus 6, 2 times 3, right? X squared. There you go. That's it. But you have to do this distribution right now. In the next section, we'll be able to deal with it, just like I said. We'll be able to do that without having to do this. And that will be the product rule, but we're just not there yet. All right, let's look at 11. G of t is 2t to the negative 3/4. All right, well, pretty straightforward in terms of, it's just a single term, so I can take the derivative pretty simply. 2 is a constant attached to a function, so it'll come for the ride. And now I need to take the derivative of t to the negative 3/4. I need that derivative, so I'm going to do that right here. All right, so negative 3/4 is the power, it comes out in front. Then I take t, and then I take the negative 3/4, and I subtract 1. And to do that subtraction up there in the exponent, I need a common denominator. So I look at this as being a 1 over 1, and then get a common denominator of 4. So it's negative 3/4 minus 4 over 4. And that becomes negative 3/4 t to the, when we subtract these, we get negative 7/4. And that's it. So we come back here, we've got 2, and then we have times negative 3/4, and then t to the negative 7/4. And I can put these two together, multiplying this, I get negative 6 over 4, it reduces, so you get negative 3 over 2, negative 3 halves, t to the negative 7/4. And it's perfectly fine to leave that answer like that, but you can also use the fact that t to the negative 7/4 is the same as 1 over t to the positive 7/4. That's just from algebra, rules of exponents. And you can just multiply straight across now, and this would become negative 3 over the 2 times this, so 2t to the 7/4. We just need to be comfortable going from here to here, and if we had to go backwards, here to here. So that's correct, and so is that. All right, number 12, cy to the negative 6. b of y equals cy to the negative 6. This is number 12. All right, so it's important for us to understand here that the variable, the independent variable in the problem is y. Then we have this c here. What's that? Well, that's just some constant. They're just not telling us what it is. So we'll treat it like a constant. When we take the derivative, since this is a constant times some function of y, it'll come for the ride. Then I'll say times the derivative of y to the 6, negative 6. And to do that, y to the negative 6, the negative 6 comes out, so I'm going to put negative 6 here. Then y to the negative 6 minus 1. So I have to subtract 1 from negative 6. Be careful there. That's, let me put these two together. That's a constant times negative 6. That's just negative 6 times that constant, whatever it is. Y to the negative 7. That's correct. You can leave it like that. Or you could write this. So what I did was I rewrote this as 1 over y to the 7th, and then I put them together and I got this. Where am I at? 13. Capital A of S equals negative 12, or negative 12 over S to the 5th power. Negative 12 over S to the 5th power. All right, well, you can make this hard or you can make it easy. Let's see. All I'm going to do is use properties of exponents first to get this back to a single line instead of a fraction. Because right now, up to this point, we don't know how to deal with taking the derivatives of fractions, or what we call quotients. We will have a rule for that later. But for this, we can just say this is the same as negative 12 s to the negative 5. So just rewrite it first. And then when you come to take the derivative, we have product here between a constant times a function of s. So the constant comes along, negative 12, times, now the derivative of s to the negative 5, the negative 5 comes out, so I've got negative 5 here. S to the, well, I take negative 5 and I subtract 1, I get negative 6. So this is negative 6. And then I put those two together, 50, 60, I think, 60, my goodness. S to the negative 6, which is correct. I could also write 60 over s to the 6th. Either one of those is fine. So again, dropping it down, just get used to it. All right, number 15. 3a plus 1 squared. Capital R of A equals 3a plus 1 squared. This is number 15. So here, what I'm going to do is realize that I actually have a product here of two things. So this squared is the same as 3a plus 1 times 3a plus 1. Now we have to do it this way. Later on we'll have a shorter way of doing it. But for now, the best we can do is take derivatives of our variable to powers, like, you know, x to the 5th, x to the negative 5. Something like that. But when we have something complicated like a binomial that's being squared, we can't just take the derivative of each one. It's not that simple. So I'm going to do this first, and then I'm going to FOIL. So I'm not doing any derivative yet. I'm just cleaning this up algebraically. This is 9a squared plus 6a plus 1. So that's an equivalent statement or expression. And now this is 3 terms, and I can differentiate each one term by term. So I'll go quick through this one. All right, 9 is going to come along for the ride. Derivative of a squared is 2a. 9 times 2 is 18. So 18a. Here, derivative of 6 times a, well, cover up the 6. It's going to come for the ride. Derivative of a is 1. So it's just going to be plus 6. And then derivative of a constant is 0. So that's it. 17, root p minus p. S of p equals root p minus p. All right, well that's 2 terms. I can take derivative of each one. But the rule that we're working with, this power rule, says x to the n, or like our variable to the n power. So I'm going to first convert that root p to p to the 1/2 minus p, like that. Then I'll take the derivative. So s prime of p equals, now be careful on this one. The 1/2 is going to come down. So here's our 1/2. P, and then we're going to take 1/2 and we're going to subtract 1 from it. Now here, I can cover up the minus and ignore it for now. Derivative of p is the same as saying like the derivative of x, so that's just 1. And you have to figure this out. So you get a common denominator, 1/2 minus 2 over 2, that's negative 1/2. And we will have 1/2 p to the negative 1/2 minus 1. Now, if you wanted to, you could rewrite this because it's a negative exponent. You could drop it down to the bottom. It would join up with the 2 down there. You get 2p to the 1/2 minus 1. And then you could go back and remember that p to the 1/2 is a square root. So you could write 1 over 2 square root of p minus 1. And that would be your final answer. Now in class, I know for sure, I tell you that, look, square root, you just need to know the derivative of. So let me remind you, in class, I'm sure I'm going to tell you, the square root, if you're going to take derivative of the square root of x, this is equal to 1 over 2 root x. You just put that into the memory banks. It happens so much. It's just faster if you do this than if you go and you convert it to half and then do all this stuff and go back and eventually get to this. Just memorize this one. So I could have just said, look, derivative square root of p is 1 over 2 root p. 1 over 2 root p, and just be done. All right, I'm already tired of doing problems. 19. Y equals x squared plus 4x plus 3 all over root x. All right, now we finally have an interesting problem. Because this one, we cannot do, I mean, the temptation here is just to say, hey, if I want to take derivative, I'll just do derivative of that, derivative of that, derivative of that, and I'll divide it by the derivative of that. That is not the way it works, unfortunately. So our only hope is to try and make these powers of x all on one line without the fraction, which I can do if I just remember what these things mean. So the bottom, remember, is x to the half, like that. And because I have a single denominator in 3 terms up top, I can split this up into 3 fractions. Now, again, I'm not doing any of the calculus yet. I'm just doing algebra, trying to get x to the n, right? I'm trying to get these x to the n, but without the fraction, without the big fraction. So all of these somehow need to be looked at as powers of x. So properties of exponents, what you'll do here is you'll do x to this power minus this power. So 2 minus a half. This will become plus, this 4 is just here. And then this is a 1 up there, so you get x to the 1 minus a half. And then this last one, I don't have an x on top, so what I'm going to do is just push that one up. So I have the 3 there. When the x goes up, it becomes negative, becomes raised to the negative 1/2. So we're just going backwards. Instead of dropping it down, we're pushing it back up. Now we have like x to a power, x to a power, x to a power, and that we can differentiate. So let me do this. You have to get a common denominator here. So you turn this 2 over 1 into a 4 over 2, then subtract, you get 3 halves, plus 4, this one, 1 minus a half is a half, and then plus 3, and then x to the negative 1/2. So I'm ready now to take the derivative. So here it comes. Y prime equals. All right, so here I'm going to do, the 3 halves going to pop out, 3 halves, x to the 3 halves, take away 1. Okay, I'll do that in a second. Plus 4. Okay, and now going to bring the 1/2 out in front. So times a half, x to the 1/2, take away 1. By the way, you may notice that's the square root of x, but I'm doing it kind of the longer way here. This one right here, we have the plus 3. And then x to the negative 1/2, take away 1. So I need to do some fraction subtraction up here, and I should be there at the answer. So 3 halves, x to the 3 halves minus 1, that should give you 1/2, plus 4 times a half is 2. X to the 1/2 take away 1 is negative 1/2. And then plus 3, wait a minute, did I bring out the 1/2? I didn't bring out the 1/2. Why didn't I bring out I was supposed to bring out the negative 1/2. Glad I caught that. When I take derivative here, the negative 1/2 comes out. Then x to the negative 1/2 minus 1. My apologies. That's that last one right there. So when I do the 3 times the negative 1/2, I actually get negative 3/2. And then x to the negative 1/2 minus 1, get a common denominator, you should get negative 3/2. That should be it. We can just leave it like that. Yeah, okay. 20. G of u equals root 2u plus root 3u. Now, there's something subtle here in this problem that they're trying to get you to see. In the first term, root 2u, the u is not underneath the square root. In the second term, root 3u, the u is underneath the root. And so that's going to make a big difference when it comes to taking the derivative. So here's what I'm going to do. First, I'm just going to rewrite this so it's a little easier for you to recognize. Root 2 times u, that's what we got in the first one. Plus, check this out, root 3 times root u. I'm allowed to do that because properties of radicals, if you have a product inside, you can split it up. And that's going to be root 2 times u plus, well, I could have just left it. Let me leave it. Just leave it. I was thinking about what I'm going to do. I'm going to take the derivative. This is a constant times the function, so derivative of this, the constant's going to come. Derivative of u is easy. This is a constant times a function of u. The derivative of that's one of the things I said you need to memorize. I was going to rewrite as u to the half, but that would kind of defeat the whole purpose of me telling you to memorize that. So g prime of u, let's just do this. This comes for the ride, root 2. Derivative of u is the same as saying what's the derivative of x. So that's just 1 plus root 3 comes for the ride. And then the derivative of the square root of something is 1 over 2 times the square root of that something. So derivative of root u is 1 over 2 root u. And the only thing really you could do is like take this root 3 and throw it on top there. Like that, plus that. So we're there. That's it. 21. 21. V equals t squared minus 1 over the 4th root of t cubed. So I do have 2 terms, all right? That's nice. But I'd like them all to be like t to a power. So I'm going to just convert this one over first. This is t squared minus 1 over t to the 3/4 power. That's what this means. It means cube it, but then take the 4th root, so that's 3/4. And then I'm going to bring this up so it's not a fraction and rewrite it as t squared minus t to the negative 3/4. And now I'm ready to take the derivative. So the derivative of v is the derivative of t squared. So 2 drops out, 2t, subtract 1, you get t to the 1st power. Here we have a minus sign. We're going to drop out the exponent, negative 3/4 will be multiplied there. And then t to the negative 3/4 minus 1. So I'll need a common denominator there. I just write 4 over 4. There we go. And so you get 2t plus, because I have negative minus, or minus a negative, which is going to be plus 3/4 t to the negative 7/4. And one other way you could write that would be 2t plus, the 3 is on top, there's a 4 on the bottom, and then this drops down and joins the 4, t to the 7/4. And that's fine. Just keep in mind also, when you have t to the 7/4, this is the same as the 4th root of t to the 7th. And that you could even go further and write t to the 4th times t cubed, because that's t to the 7th. And the reason I did 4 and 3 was because I'm doing 4th root. I could now even split this up into 2 roots. And the 4th root of t to the 4th, that's just going to be t. And then you have this still. So you could even write 2t plus 3 over 4. This is t, then 4th root of t cubed. You could write that. All of these would be okay answers with me. '23. Let me go check. Well, okay, z equals a over y to the 10th plus b cosine y. Now, one very good question you could have here is, what is the independent variable? Is it a, is it b, is it y? So they don't specify it here. Like, to specify it, I would need to write something like z of y, and that would tell you that y is the independent variable. So here's what you need to know. In this book, most commonly the variables can be like x, y, even z, r, s, t. But anytime you see like an a, a b, or a c, or a d, or something like that, or capital or lowercase, doesn't matter. Those usually tell you that you're dealing with constants. So this is a constant, this is a constant, they're just not telling you what it is. So it's kind of implied here that y is the variable. All right, so with that in mind, let me first try and rewrite this so that I have y to a power. So a y to the negative 10, I'm bringing this up, okay? And then the other part, I should be okay with taking the derivative. I don't need to do anything to that. So let's look at the derivative. All right, a is a constant. It's attached to the function. It's going to come for the ride. But the negative 10 is going to come out and multiply times this. So I'm going to have negative 10 times that a, then y to the negative 10 subtract 1. So I'm using the power rule there. And then plus b times the function. It'll just come for the ride. But derivative of cosine of y is negative sine y. I'm putting it in parentheses there because that's multiplication, not subtraction. And this can be, oh, I forgot to put prime, sorry. This will be negative 10a y to the negative 11. And then when I put these together, it'll become negative. So I'm going to put minus b sine y. There we go. You could drop that down back below this as a positive 11 power, but I'm just going to leave it. Ooh, 24 is interesting. 24 is interesting because they're using like other letters and it throws people off. Y equals sine theta over 2. And then plus c over theta. All right, here, c is our constant, is a constant. Theta is our variable. Theta is basically like an x. So you're trying to take derivative. You've got two terms, and we can do them individually. I'm first going to rewrite this, all right? So look, this right here, although it looks confusing, is really just 1/2 times sine of theta. That's all that is. And then the last part, because theta is my variable, I don't want it down here. I need to bring it up. So this will be c times theta to the negative 1. And now I can differentiate each one. So derivative is, well, what's the 1/2 just going to come for the ride because it's attached to the function. So 1/2 derivative of sine of theta would be cosine of theta. And then plus c, my constant comes for the ride because it's attached to the function. Negative 1 comes out, right? So this negative 1 drops out, multiplies times the c. That'd make it negative c, so let's do that now. And then I get theta, and I subtract 1 from -1, I get to the -2. And that's it. You could drop the theta back underneath this, the c as a theta squared, but I'll just leave it there. And 26. U equals, I can't even read this. U equals the cube root of t squared plus 2 square roots of t cubed. Now, I'm going to try and rewrite these two terms as powers of t. So the first one is t to the 2/3 plus 2 times this is t to the 3/2. So the power, you can look at it this way. The power is 2, the root is the denominator. Power is 2, root is denominator. Here, power is 3, the square root, there's a 2 out here, is the denominator here. So there's the function. Let's take its derivative. So this is pretty straightforward. 2/3 is going to pop out, 2/3, t to the 2/3 minus 1, plus the 2 that comes along for the ride, but the 3/2 pops out, t to the 3/2 minus 1. This is 2/3 t to the, if you do this subtraction, get a common denominator, -1/3. And then when I do this multiplication, the 2's cancel, so I just get plus 3. T, 3/2 minus 1, get a common denominator, you get 1/2. That's it. All right, I'm going to do 27, and then I think I'm going to take a little break. Although you're not going to know, right? The video is just going to skip and then come right back. I had a student point that out to me, which I know, but still. All right, number 27, find the equations of the tangent line and the normal line to the given point. Okay, so let me see if, let me do it this way. All right, so let me put the function up here, the curve, y equals 6 cosine x, and I want to look at the point pi over 3, 3. All right, so if I were to graph this curve, it's a cosine curve, 6 in front is the amplitude, so that means that it's 6 here and -6 here. And since it's a cosine curve, it has a period of 2 pi, right? And it starts up here, ends up here, and does something like this. Roughly, okay? Roughly. Now, at pi over 3, if we were to plug pi over 3 into that, we would be at, this is pi over 3. If we plug it in, we get 3. So this is the point pi over 3, 3. What we want to know are two things. What is the equation of this tangent line? And then, what is the equation of what we call the normal line, which will be the line that is perpendicular to the tangent line. So we want the red line's equation, we want the blue line's equation. So let's work on the red line's equation first. Well, I need to know the slope of that line. And the slope of that line requires the derivative. So let me take the derivative quickly. The 6 comes for the ride. Derivative of cosine of x is negative sine x. That negative gets applied to the 6, and we have this. So if I want to know the slope of a tangent line on this curve, right, it comes from this formula. And so the slope, right, of the tangent line at that point requires that I plug in pi over 3 into this. So sine of pi over 3. Now, what is sine of pi over 3? Well, that's why you took pre-cal. So this is going to be negative 6. Sine of pi over 3 is root 3 over 2. And this just turns out to be, let's see, 6 and that's negative 3 root 3. Wow, that's a weird slope. Don't use a decimal, okay? We want exact values here. So this is the slope of the tangent line. Look, it's negative. That makes sense, right? I mean, it matches. All right, that gives us just the slope. We want the equation of this line. So this is where we go back to that formula. Y minus y1 equals m times x minus x1. And I know my y1 is 3. My slope I just found, negative 3 root 3. And then x minus x1, which is pi over 3. I'm not going to solve this for y. I'm just going to leave it like this and box it. That is the equation of that red line. Now, the only difference between the red line and the blue line, right, they both go through the same point. So they both have this as an x1, y1. The only difference is the slope. And remember from college algebra, if you have the slope of a line, if you want to find the slope of a line that's perpendicular, which this one is, the blue one is, all you have to do is use the negative reciprocal of the slope. So that means just take the slope that we have here and do the reciprocal of it and change the sign. So the slope of the blue line, okay, the slope of this blue line is going to be that flipped over, so right is 1 over 3 root 3. It was negative, so now it's going to be positive. Okay, so that is the slope of this blue line. And then all you have to do is just do that equation again. So you have y minus, same y1, so y minus 3 equals this slope instead. And then x minus pi over 3. There you go. That's it. That's the equation of the normal line. This is the equation of the tangent line. Normal line there, tangent line here. Someone might say, hey, you can't leave a root in the denominator. Yes, you can. It's not against the law to do that. If you did rationalize it, though, just so I can make some people happy that don't like that, you would multiply the top and bottom by root 3 here. These two would go together and become a 3, and then I would have a root 3 on top, so it's root 3 over, these two were 3, and then times 3, so that would be 9 down here. So root 3 over 9 would be the same as that, but I'm just going to leave it. All right, let me see what time it is, or how long this video is. Yeah, that's about right. Okay, so quick little break.